Ever wondered how magnets actually work? You've probably heard explanations based on magnetic domains, saying a magnet is made of smaller magnets which are aligned together, called domains, and that creates its external magnetic field. But that's definitely not the full story. Turns out magnets are based on photons. Yes, that's right. Photons, the same particles that light is made of. Well, in fact, not real photons. Magnetic fields are based on virtual photons. That is, photons that are very short-lived. In fact, they don't even really exist. Their existence is limited by the uncertainty principle. As far as external observations and measurements are concerned, these photons never exist. But why would we ever use virtual photons in a theory? So let's think about a simple case. Light is photons, right? But so is infrared, it's just light at a different wavelength. And so are microwaves and radio waves too. But at what point do you transfer from an electromagnetic radiation to simply an oscillating electromagnetic field? So technically, why wouldn't alternating current in a wire be considered a form of electromagnetic radiation? And if we push this reasoning a little, well, what's to prevent a static electromagnetic field from being modeled as photons? But there obviously isn't energy going back and forth between two static electrons in the form of light. So that means that these virtual photons must first not really respect the classical relationships between energy and momentum, and secondly, we can visualize them as small waves which do not truly exist in the sense that we can observe or measure them, but can have effects by distorting the background electromagnetic field. That's not a real explanation for the model, just an intuitive way of seeing the links between photons and electromagnetic forces. And also, from the point of view of the Lorentz force, since a photon is modeled as an alternating electromagnetic field, it also explains very nicely why electrons would repel each other. At that point, it just becomes a matter of evaluating the Lorentz force created by the virtual photons on them. But what is the link with magnets? So let's imagine an infinite line of electrons. Now, if we place an electron next to it, it will receive an electric force from all electrons above it and an electric force from all electrons below it. So it should receive as much force from above it as from below it. But since the electric force is caused by photons, and since those photons move at the speed of light, it means that if the electron is moving, the photons coming from in front of it will reach it faster than those coming from behind it. This modification to the electrostatic force caused by relativity is called the magnetic force. In the case of a magnet, the motion of electrons around nuclei and the spin of electrons causes the motion required for the magnetic field.